So what is third law? Third law says that equal and opposite reaction. For every action, there is an equal and opposite reaction. So first, we should understand what is action and what is reaction, because action is a very vague word. Action is a very general word which is used in many contexts. Suppose some people were doing protest in front of government house, then the police took some action against them. So that is also called action. So that action is not used here. So action in physics means force. Action means force. And the force is the physical force that we are studying in physics. In general language also, in social sciences or in other subjects also, we discuss force. So this rapid action force is there, CRPF is there are many other kind of police force is there. So these are also called force. Military force is there. So these forces are not there, but these forces are not considered here. But we are discussing the force of physics. So action means force, and reaction means also force. Reaction means force. So for a given, if an object applies a force on other object, suppose we have an object A, if object A applies a force on object B, suppose we call it FBA, the force on B due to A, then A will also experience a force due to B. So the forces always appear in pairs. The forces always appear in pairs, and these two forces will be equal in magnitude and opposite in direction. So we can say that FAB will be equal to minus FBA. So if we have two objects, the forces on two objects will be always forces between two objects. If one object applies a force on second object, then second object will also apply a force on the first object. So the example for this, if a bullet is fired from the gun, the gun applies a force on the bullet, the bullet moves in forward direction, the bullet also applies the force on the gun, so the gun is recoiled back. Similarly, we can see example and we will see properties also. So firing of bullet. Firing of bullet and recoil of gun. So this is example of action reaction. This force is this action reaction pair is always applicable. Wherever a force is applied, at all places you will have a reaction force. So this is, I am giving you just some examples, but this system, this third law is applicable in every case. Okay, now we can see other examples. Suppose you are walking on a boat. So when you try to walk on a boat in forward direction, you will notice that the boat tries to move in backward direction. So why the boat tries to move in backward direction? Because when you walk in forward direction on the boat, you apply a force on the boat in backward direction. So if a person walks on boat in forward direction, then boat also experiences force in backward direction. Okay, so you may think that, so if it is there in boat, then why this doesn't occur on Earth's surface? So if we are on Earth's surface, if we are trying to move in forward direction on Earth, why does not we apply the force on Earth in backward direction? We apply the force in backward direction on Earth also, and by the same amount. Suppose you try to push the Earth in backward direction by a force of 20 Newton, then the Earth will also exert a force of 20 Newton on you, and because of that force you start moving. So you start moving in forward direction. Suppose by applying a 20 Newton force, then the Earth's surface will experience a force of 20 Newton in backward direction. But since the Earth is very, very heavy, the Earth does not move by this small force of 20 Newton. So this is the main reason the Earth remains stationary. But the boat may start moving because boat is not that much heavy. The boat is not as heavy as Earth. Similarly, you can have example of walking that we have been. This is walking. Walking is the example. In walking, we push the Earth in backward direction. Pushing Earth in backward direction. Pushing Earth, but Earth does not move. Earth in backward direction. Okay. Similarly, we have many examples. So propulsion of rocket. So a rocket, when the fuel burns, the burnt out fuel, the smoke part, will move in backward direction. So there is a force applied on the smoke in backward direction, and as a result, a forward direction force will be applied on the rocket part. So if you consider a rocket, the smoke is going to move in backward direction and the rocket is going to move in forward direction. So the backward force is applied on the smoke and forward force is applied on the rocket. Then we can have some more example. Suppose you want to ओके बोलिए, इसमें डाउट है कि
सर वो क्या लिखें, propulsion of rocket?
रॉकेट, हाँ, propulsion of rocket. ठीक है, सारे फोर्सेज एक्चुअली ऐसे ही लगते हैं, कोई फोर्स ऐसा है नहीं जिसमें एग्जांपल ना हो एक्चुअली. ठीक है, बट वो नोटिस में नहीं आता है. जैसे कि मैंने एग्जांपल दिया ना अर्थ पर, तो वो नोट हम लोग को एक्सपीरियंस में डे टू डे नहीं आ पाता है, बट फोर्स हमेशा लगता है, हमेशा फोर्स ये लगता है. ठीक है, तो हम लोग इसका प्रॉपर्टीज देखेंगे. व्हाट आर द प्रॉपर्टीज, इसका थर्ड लॉ का क्या क्या प्रॉपर्टीज होता है, कैसे ये लगता है. ठीक है, ओके, इतने ही एग्जांपल देखते हैं. सो इसका क्या क्या होता है, इसका पॉइंट्स क्या क्या होते हैं. तो इंपॉर्टेंट पॉइंट्स, important points. All the forces appear in pairs. All forces appear in pairs. One is called action and other one is called reaction. Action and reaction. So we do not have a isolated force. We do not have a single force. Only one force. We cannot have only one force. The forces, whenever a force will appear, it will have a pair related to it. So the forces always appear in pairs, and these two pairs appear simultaneously. Simultaneously means it is not like cause and effect related. Means if a force F1 is appearing, then as a reaction F2 will appear. It is not like that. It is like F1 and F2 will start acting simultaneously. So action and reaction appear simultaneously. Simultaneously means not one after another, not one after another, not one after other. Okay, then these two forces are equal in magnitude, opposite in direction. Equal in magnitude and opposite in direction. Okay, but one thing we should keep in mind, all forces which are equal in magnitude and opposite in direction may or may not form the action reaction pair. What I'm saying is, if we are given two forces, if the two forces are equal in magnitude and opposite in direction, they may form the action reaction pair or they may not form the action reaction pair. It is not a compulsory criterion, we can say. See, this is the criteria, but if the two forces satisfying these two relations, they may not be the action reaction pairs. They may be acting on two different objects. They may be unrelated, but their forces are equal and direction are opposite. We can have that forces. For example, we have one object here, another object here, another object here, another here. So if a force, suppose 10 Newton is acting from this object, F of 10 Newton is acting, and on this one again we are having 10 Newton. But these two are different. The direction of force is opposite. The magnitude is also same, 10 Newton, 10 Newton. But these two are not action reaction pair. The reaction pair of this one will be coming from the object which is applying the force on it, and similarly the reaction pairs of lower one will be on the object which is applying the force on these two objects. So if two forces are just equal and opposite, they may not be the action reaction pair. So this also should be kept in mind. One more thing we should keep in mind: action reaction pair forces always acts on two different objects. They will not act on same object. So action and reaction act on two different objects. They will not act on same object. If they will act on same object, they will simply cancel because their magnitude is same and direction is opposite. So they will simply cancel. If they will cancel, no object is going to move. These laws are universal laws, so they are applied for every force. So if all the forces are balanced, if you see the action reaction pair, if action and reaction are acting on the same objects, then what will happen? All the objects will have all the forces balanced, so no object is going to move. So this is not going to happen. The action reaction act on two different objects. So